Are you gonna keep going? You gonna put that over there? Yeah, I don't want to just like bring all the way up to the front. That's what the ramp do. Use the ramp to go.
What is he talking about?
Everything he said is correct. Yeah. So we could get the ramp to this height by lifting it straight up. The box. Yeah, but you could lift the box straight up. You gotta have big time muscles for that. If you use a ramp. Right, you're gonna use you're gonna lift the entire weight. Full force. Weight you're counteract the entire weight of the box. Yeah, it's too heavy for you, so you gotta use the ramp to make it easy. So if instead you get to that height by lifting the box up the ramp. The ramp helps you, takes on some of that force. The trade-off is that you've got to push the box over the diagonal. You got to be careful with the type of ramp you use. A longer ramp. Yeah, but you have to be careful with the type of ramp you use because the friction might be too great to push up on it. Okay, we're assuming this is an ideal situation. Friction is a good point. Yo, don't try to be like this. So you can lift the box straight up over a short distance and push it away. Or you can push it over a long distance and let the mechanical advantage of the ramp help you. So, like Prince said, it makes your job easier because the force you put in can be less than you lifting the box straight up. The trade-off being you got to push it over a longer distance. So if you're willing to push it farther for less force, then a ramp is your tool of choice. All right. So most of the time, people are more than willing to push it a little farther if they're pushing with less force. So that's why a ramp is a very useful tool. It's one of the simple machines. All right. We'll talk about that. Carlos, does that help? So the mechanical advantage formula is where it's at. If you want to look at it from that perspective. Now to work in both cases, call this case 1, this case 2. Amount of work in case 1 it's got to be the same in case 2. Okay, so if you're the amount of work in the box is the same. Applying force. Same. Well, so in this case, force. Definitely can't switch it from the fact that the work it's got these things. So for a particular ramp, if you compare the output force you're putting over the input force, that's how much greater that mechanical advantage is. So you use the same formula in both cases. What you'll find out is the distance is longer in case 2, force less. In case 1, the force is greater. Same work done in place. All right. You say they're grody. What? Yeah, they was funny. I never said that. That's why. Alright, so we're going to build some tools to help us do work and analyze and calculate the minutes to figure out how much work And to do that, you're going to need to build the mechanism to do that. So in order to do that, you're going to have to be familiar with the building system. That's called VEX. Did anybody use the VEX system in the past? I don't want to now, but so it's a building system that the school has invested a lot of money in. Basically using its steel components with holes in it. The steel strength is about the same, or pretty significant, but by putting the holes in it, you're getting a lot less of the weight. The steel is known to be very strong, but on the heavy side for its strength. So a lot of the VEX components will have these square holes in it to give you the strength but reduce the weight. So there's a whole fastener system that comes with it that helps you connect pieces of the steel pieces together. If you put motors on it, and you put a computer program on to control those motors, and as well as sensors, you now have a control system, otherwise known as a robot. In the end, you use it to accomplish tasks, but you're doing design and engineering. Question, sir?
Why is it still usually aluminum?
You're correct. I mean, you have a choice. Engineers always have a choice as to which material they use in a situation. Every material, no material is perfect for every situation. There's going to be trade-offs as well. If you use aluminum, you're going to find it's not as strong as steel. But then the trade-off here is that aluminum or steel can rust, or aluminum can not rust. Right. So it depends on the molecular bonds, you learn about chemistry, and the particular element that's made up of are molecules that the properties. So a huge part of engineering is analyzing materials, figuring out what the trade-offs are, and making your selections for that. So since we're not going to put these underwater, prints are getting exposed to any kind of water source. So
I mean, it's exposed to water.
Steel. You're right. We're going to put it out the factory. That's exactly what happens sometimes in real world scenarios. So you have to calculate. You can put coatings on steel to prevent or slow the corrosion, called galvanization process. Oxidation. Stainless steel has a oxidative process, but you can't prevent it 100%.
I can smell it.
All right, so there's going to be. So what we're going to do is organize some of these components to build some mechanisms in the back here. Now, let me just summarize what you're going to be working with so that we're all on the same page. We're going to give you some building instructions to step-by-step build certain mechanisms that you can perform an investigation with. So you'll have step-by-step instructions on what to build here when we first phase. Later on in the semester, you'll be building some custom designed structures with it. So knowing and getting familiar with how to build it, using the fasteners and using the pieces is the beginning of getting familiarity with it. You should begin now. So what I've done is I did not sort out every single individual type of piece in this kit system. What we have done is sort it by general categories. So all the metal components are in, for example. All of the different tools that are used in this system are in this. All the different ways to connect and fasten materials together, like screws, nuts, bearings, little pins, many other kinds here are in one minute. So I'm not trying, I think I found that sorting it down every single individual part is not productive use of your time, but putting it in the general categories is worthwhile. If you're just like with the Lego stuff, like spend more than 5 minutes looking for a part, stop and ask for maybe your help or ask somebody else for help. I don't want you spending time looking for a component. Sometimes we don't have it in stock, and that's why you can't find it. One thing we will be getting into as well, there's a whole bit of sensors. All right, one thing that makes a certain kind of technology called robotics unique is that not only does it help us solve problems, but it automatically, electronically has sensory devices allowing it to interact with the environment. And then if you use a program or computer science here to process that sensory information, you can then act on it and make better decisions with that information so that it can do things on its own. So you human beings are not to be there for every single step of the way. So there's a whole bin of sensors. Some of them sense light, some of them sense rotation, some of them sense pressure. Some of them sense light in different ways than our eyeballs would sense. Some of them sense just the intensity of light or the color. Others are color sensors, as well as little kind of like light bulbs in here, as well as like flashlights for certain applications. So there's a bit of sensors, there's a bit of fasteners, there's a bit of sheet metal pieces, and there's a bit of tools. So please respect our classroom environment here and try to keep the parts sorted in those general categories, not sorted down to the individual type of part. So when you pull some parts out of your bin to build something, don't just dump them in any random bin here. Try to put them in their general category. All right, so you're certainly welcome to, when you're building, take some of the parts out of those, you can do accomplish your tasks. But don't take them all because we're sharing these general bins. If you have some more parts than we're out here, so if you run out for some reason, let me know. We'll try to replenish. All right, so what I've tried to do over the years here has been a pretty major effort to build some of these things, and it ends up taking more time than we'd like. So I tried to keep some of the things that have been built in the past partially built, so we don't have to rebuild everything from scratch. However, they're not always perfectly made. They need to be tuned up and finished. So what we'd like to do is have some individuals help us with the building process to make sure that our structures this semester are properly built to the instructions and specifications. So if you want to get involved in the building process, we're going to be asking for some volunteers to help out with that. We have instructions, color printouts to help you understand how to exactly build it. So there's 2 or 3 components that we need some help being built. So what I guess I don't want you to do is, if you're building one system, like this control system test bed, I don't want you to take apart something that is intended for another project in here, like the fuel cell car or the simple machines apparatus. So when you're pulling parts for your assigned building project, don't pull them from previously built stuff. Please take them only from the bins that have been sorted. Is that clear? All right, you're going to upset other people in this class. You'll upset me, upset yourselves and your teammates, because it's going to end up causing us more time to finish building what we need. All right, so please, if there's any doubt, please ask first.
Just hold on. Just hold on. It's hard to stay young. Just hold on.
Another thing I'd like you to come back and take a look at here in the remaining time, I have some potential projects from product dissection that we'll be doing over the next month in new teams. I want you to think about products you bring home. We got some credit for the these. So take a look at these when you get a chance here today or this week. About what products you can dissect that part to analyze.
Taylor. Can I use the bathroom?
Yeah,
Okay.
No, you can't use it.
So there's some options back here potentially for next session. We can start to recognize some state rules.
Just go away. You're a good girl.
Yeah.
You're a good one. Give you
So what we'd like to do is have
just go home.
So I'm going to show you somebody in your group that's going to be assigned to what we're writing out. You're going to need a person that will be continuing on in the next group. Who's going to be an elder? Discussing that now.
I'm good. Hold on. I'm good.
Elders feel way up there. You want to be here? Everybody's gonna have some home play process, but
It's because like, I didn't forget to run.
Lon, look at this girl. Look at her. What's wrong with her hair? It's like, yeah. That's Lee.
Lead.
Yeah.
Yeah, like it. So how's that gonna work?
on the session one here.
Rainer. Means Rainer. I'm gonna say.
So for the remaining time today, these chapter 12, section 2, they take those to the vocab. We'll do that tomorrow. The read section 2. Just hold on. Let's have some of these. What our chapter section review, and we'll do the building tomorrow.
I saw a block Tetris.
Yeah, that's how you play it.
Yeah. Is it still recording? Put this at the maximum box.
Somebody's mad.
Alright, everybody's got the assignment for homework here. You can get it down, read section 2, take those in the vocab. I sketched some basic pictures here with some machines, especially if you've never used them before. If anybody wants to help do some building after school as well, if you want to get very familiar with the system, you're certainly more than welcome to do that. The team that qualified for state's competition built their rollout of district for kids. We got qualified to state first place this year. We got qualified for district. Well, we also qualified for state and well, we go from regionals right to
You know what districts are?
District as the state.
No, districts, I'm talking about swimming districts.
Oh, swimming is completely different. That's athletics.
Yeah.
Yeah.
No.
Muscles.
Send me the link to the TITres. The thing is green, okay?
You take it
I
off.
wasn't
Message.
looking. I can't even hear it. I wasn't paying attention.
You're not showing your work. You're not substituting the correct place. So the people that are very interested in grading, right, have to do a section 1 review. That's a different subject. So you're graded for section 1 review. I can get it to you. Right? Well, this is section 1 review. I'll try to publish these out.
Someone's supposed to they didn't do.
Eric, if you turn this in late, 5% of data. Check why you're not ready now.